Hi, I'm Brian Preventa with TESCO, the Eastern Specialty Company. Today I'm going to be demonstrating how to operate the TESCO RF meter, catalog number 1120. The RF meter is a simple solution to demonstrate to residential customers or commercial customers how little RF is actually emitting from their RF meter or AMI meter. So to get started, you'll want to set your meter to the RF setting here. And one thing to note is that the sensor for the meter is in the top right corner here. You want to make sure not to cup the sensor on the RF meter because this will affect your readings. Another thing to note is that you'll also want to make sure when you are taking readings to point the RF meter directly at your RF source. This is a directional tool. The sensor in the meter only emits one direction, so you always want to point your tool at your RF source, like so. Okay, so here I'm going to demonstrate the effects of a wireless doorbell with our RF meter to see how much RF is emitting from the wireless doorbell. This can be used as a baseline to show you how our meter reacts to a constant RF source. So I'll go ahead and push this button down, just hold it down, and you can see that the wireless doorbell is emitting about 0.05 milliwatts per centimeter squared. This is a constant reading, so it gives a good example of how our RF meter reacts to a constant RF source. Now if I move this wireless doorbell back just about another 3 inches, so we're at about 6 inches away, and if I push this down once again, the reading is virtually gone. We're at about 0.01 milliwatts per centimeter squared, and you can see just as I move it up towards the meter how the needle begins to creep back up ever so slightly. Our next demonstration is going to be with a microwave oven. So with that, I will hit this to 20 seconds, and I'll hold the RF meter with our setting turned to RF just about 1.5 to 2 feet away. With that, I'll hit start. You can see with the microwave oven, the needle begins to peg at almost 1 milliwatt per centimeter squared, which is essentially in the danger zone, just to give you an idea of the type of RF emitting from your microwave oven. If we move our microwave about 5 feet away, I'll give you another example of how your RF diminishes, even from a microwave oven, which is considered a high RF source. With that, I'll hit this to 20 seconds once again. You can see that the needle still begins to jump, not quite to 1 milliwatt per centimeter squared, but right around 0.2 to 0.3. And this is at about 5.5 feet away from our RF source. Okay, for this demonstration, I'm going to show you the effects of an AMI meter with our RF meter. Now, the AMI meter is powered and running, there's voltage applied, and when I first powered the meter, the RF needle here did begin to spike, and that's typical for an RF meter. As they power up, they'll essentially search for a signal and then they go to rest. Now with this particular meter, I've noticed every 1.5 to 2 minutes that the needle here did begin to spike at about 0.05 to 0.1 milliwatts per centimeter squared. So with that, we'll just sit here for just a sec, and as you can see, it just spiked to about 0.1, and now it has gone back down to 0. Okay, so here we're doing essentially the same test as the last one. We're just at about 6 feet away for this test. Right now the RF meter is sitting at rest at just about 0. So we'll give it a sec to see at what point the needle will jump. Okay, so we just sat here for just about a minute, and it seemed like our needle spiked to about 0.05 to 0.1 milliwatts per centimeter squared. And this was at a distance of about 6 feet away. You can see since then now the needle has gone back down to zero as the meter's gone back down to rest, which is typical for an AMI meter.